Okay, folks, you're doing a great job. This is pretty abstract stuff, and I want you to take some notes so that when you get on the test and you see this, you're gonna be like, "Oh, how did I do this in my homework?" We're talking about step functions. You'll notice that I numbered it as two and then 2a. So the greatest integer function is just an example of a step function. So let's first just look at what a step function is. Okay, so I'm going to go over to our textbook and let's see, I think I'm on, where to go? Right here. So this is what a step function looks like. It's like if you're walking up the stairs in your house, there's a step here and then another step and then another step. Is this even a function? Well, if you drew a vertical line, it's going to not cross through that open circle, but it will hit there, right? So it's only crossing in one spot, crossing in one spot, crossing in one spot. So it's definitely a function the way we have it set up. And they're going to use this special notation. It's like two square brackets. Let me see if I can zoom in on that. It's really weird, but do you see those little funky brackets right there? Now, let's just go to Desmos, and I'm going to show you what this looks like on Desmos, okay? Um, Desmos that I've opened right now is like this. So here's an example of a step function, okay? See how there are little steps right there? And this is actually the greatest integer function. And on Desmos, we call it floor because what the greatest integer function does is it rounds everything down to the nearest whole number that's less than or equal to the number that we're at right now. So let's talk about that for just a second, and I'll give you an example. Okay, I don't know if you've ever shipped a package on UPS, but you usually come to a screen like this where you have to type in information about your package. Now, look at this. It says the length entered is not a whole number. So the length of your box, if you measured it at 6.5 inches, it will not let you put in 6.5 inches. Let's see about like 6.7 inches. Nope. How about 6 inches? Oh yeah, it takes 6 inches. Now, if your box is 6.5 and you say six, when you get to the UPS store and they check it, they might say, no, you didn't measure this correctly. And they'll bump it up to 7 inches, right? So like if you had 6.5 inches, let's say 6.5 inches, okay, they're going to round it up to 7 inches. So let's look back at our Desmos screen. We would not want the floor. In other words, we wouldn't want it to round down. Let's go to six right here. If I was at 6.5, okay, let's see, where the heck is 6.5? Here's 5, 6. So here is 6.5. It says that it's 6 right here, right? So the y value would tell you what you should enter as the measurement. You would like the UPS company to use the floor function, but really we need the ceiling function. So I'm going to get rid of the floor function, and I'll show you where those functions are located here right now. It's down here in this little menu, and you go to functions and you scroll almost to the bottom, and you're going to see ceiling right here. Okay, so we want the ceiling function of x. Now, what? Look at that crazy looking function, right? So we want the ceiling function of x. And what that's going to do, like if I go over here to 6.5, it says you should really type in 7 inches. So anything between 6.001 and 6.999999997. Actually, when you get to 7, you should still type in 7. Okay. So this is called the ceiling function. The floor function is really the greatest integer less than or equal to function. So let's put a little picture of that down, and then we're going to talk about how we're going to manage our homework problems. Okay, so let's put an x and y axis down. Ooh, it's not drawing a line there. Why is it not drawing a line? Come on, draw a line for me. Uh-oh, let's see. Maybe my pen stopped working here. So you're going to draw an x and y axis here for me. There's the y axis. Here's our x axis. And then what I'd like you to try to do is just put some steps on there. Okay. So just like a step function could be anything really, but you would definitely want to have an open circle on one spot, if you have a closed circle down here, right? And then like an open circle right here. Okay. And so here we got an example of a step function. What I'd like to do is try a homework problem with you. So let's get back over to our homework and let's try this one right here. So select the correct function. It says this is called the greatest integer less than or equal to, or they just sometimes say greatest integer. So in other words, it's the floor function. It's going to round everything down to the nearest whole number, to the nearest integer. And so what would it look like to have the -6 on the end? Well, let's jam back over to Desmos and take a look. Okay, so we want the floor function, and then we would want -6. Okay, so let's turn off our little menu here, and let's zoom out a little bit. Okay, so you'll notice that there are just a bunch of steps on here, and we're down 6 spots, and we see this little horizontal line at -6. So let's see if we can go find that in our homework right now. So I come over here, and I want to go, oh, right here maybe. Oh, but see how they have solid points on both sides? Do we want open circles on both, or do we want solid on one side? Oh my goodness, this is a little tricky. So, well, first of all, this is definitely not it, because our function, where'd it go? Our function keeps going in both directions, left and right. So that is definitely not the right answer. Let's eliminate D. Now you'll notice both these guys, they keep going on forever. But this guy wouldn't be a function because we're crossing the vertical line would be crossing in 2 spots. So it's definitely not A. And then B, it's not going to have open circles on both of them. It's only going to have open circles on one. And it's going to have, like when you get to, let's pick a positive number. So when you get to 8, let's stick 8 into the function. 8, what is the number that's less than or equal as a whole number to 8? Well, that's 8. So what's 8 minus 6? Well, that's 2. So when I'm at 8, I should be at 2. See how there's an open circle and then it goes up here to the solid point? So 8, 2 is right there. And then everything until we get to 9. Now, when we get to 9, it jumps up to 3. Okay, so this is the correct answer. This is what we want on number 9. Okay, I'll check my answer. It'll say, yeah, you got it right. And then we're going to go to number 10, and we're going to see if we can answer some questions about the domain and stuff. So select the domain and range of the function. Well, just a second ago, we saw that there were like little jumps, right, for the range. So positive integers, no, we had negative integers present. All real numbers, no, we don't have any like 0.5 or 0.7, right? They had to be whole integer values, right? So we're looking for the word integer. Positive, no. Real numbers means like, 0.5 is good too, 0.275, whatever. All integers, that's the one we want right there. Now, is the domain all real numbers? Yeah, it was defined for every x value. You can stick in any x value you want. So you definitely want D on that one. All right, now let's just look at it again. We obviously see there's numbers missing for the range, right? There's big gaps in here for the range. So it's not all real numbers. And then all the x values are taken care of. Like if I went over here to like -8, I could come down here and I could find something at -8. It's right down there at the very bottom of my screen. So I hope I'm making this clear how to deal with the step function and that you can get some homework problems correct. Please add some notes to your notes, and good luck.